Well, yesterday we have, well, so far this week we have covered arc, sine, arc, cosine, and their compositions. Okay, so we're focused our attention on doing, being able to do trig 7a, right? So we covered the first two rows, right? We finished the first two rows of the first table. Hope you guys know what I'm referring to, right? And we know how they come from, where they come from. Memorization is not needed, right? Because we understand. We have plotted all those points. Why do we plot all those points for, right? Not to memorize them, right? To truly understand the graph. So whenever we see the graph, we, all we have done, all that foundation we have laid out will come to our rescue. Do you guys have any questions? Because if you don't have any questions, we're going to do arctangent today. Any questions?
Professor,
yes.
I had a question about, you sent a message saying that the homework graphs were like updated and corrected. I was wondering where we could find that.
It's in module homework session.
Oh, okay.
You go to module, there's a homework session, right?
Okay, I found it.
Okay, so in module, everything is in module. Your quizzes, and it's arranged by week, and there are different topics, and I'm sure you visit that place very often, right? Every week. And all the lecture, I posted many lectures in the past, in the last semester. Okay, so you can get started studying those topics. But this semester, I go by slightly different order. Okay, so I put emphasis on basic one table, so we covered all the functions. And last semester, it was done in slightly different order. Any other questions? Good morning, Christopher. All right, so with that said and done, so you should be able to do all the on trig 7, right? On trig 7, those exercise, trig 7a, those exercises are for understanding, all of these issues related to, composition of trig functions, the composition of trig functions, right? Domain and range, and where they came from, and so on and so forth. Okay, so today, and of course you can ask questions anytime. Today we're going to talk about arctangent. Okay, we know that tangent function, what's the domain of tangent? This function does not, well, is not one-to-one. Thus, it does not have inverse. But why we have arctangent? Why arctangent? Right? So it's done in the same idea. It's done in the same idea as arcsine, arccosine, as arcsine, arccosine. Okay. So recall what we did to produce inverse function for arcsine and arccosine. The common thing we did is truncation, right? We have pieces, the arctangent, right? So when I mention tangent, what comes to your mind? What comes to your mind? Domain, range, right? So let's review what's the domain and what's the range for tangent. What's the domain and range for tangent? How do you figure out? Right? It's not about memorization, guys. Okay, if it's about a memorization this semester, we don't need so much time to cover everything. Okay, I can just give you the information in the form of tables, and I finish the material in in half the semester probably, and I'm done. I can wash my hands, or for that matter, you actually don't really need me. You don't really need me, right? Because you can get all of these informations. It's all over the places online. You can find them. And there will be people out there, you pay them $10 or $20 and they will get you the information to you. No problem, right? Domain is 0, pi, range -1, +1. All right. When you see that picture, you tell me the range is from -1 to +1. And you look at the picture, you tell me the domain is 0, pi. What answers we got here? Choice A. Do we have other answers? Do we have other answers? Domain is 0, pi. Do you mean that the domain means, okay, so let me talk about what's domain. What's the meaning of domain? What's the meaning of domain? Domain is always for some function. Of course, in this case, it's tangent, right? Domain should include all the possible input the function could apply to produce. For each one of the input, it produces exactly one output. So domain is a collection of all the possible numbers. For each one of them, the function will produce exactly one output. So it will include all of those numbers. So when you tell me the domain is 0, pi, you're telling me 0, tangent 0 works, it produces exactly one output. Tangent pi works, it produces exactly one output, and that's it. That's what you're telling me. And you tell me the range is -1. So you're telling me there are only two numbers in the domain, 0, pi. And the range is from -1 to +1. That's what you're telling me, okay? So you may be providing some information to your professors, teachers. That's the interpretation of your answer. You're telling the reader, okay? You're telling the listener, whoever is there, the input can only be 0 or pi. The output can only be -1 or +1.
Can I try?
Whether that's not whether that is what you meant or not, that's the interpretation. Remember, all the interpretation is based on the definition of function. So what is the definition of function? So let's review that concept one more time. Okay, let's review that definition one more time. What is a function? I'm looking at the definition of function. You should have a definition of function in front of you on your flashcard. A function is a rule, right? A function is a rule. And then that Okay, so specify that rule that assigns to each element so the function assign to each element x in A, in a set of A, exactly one element called f of x in a set of B. In a set of B, that's the function. That's the definition of function. Okay. And then from this context, right, we say, how do we describe a rule that assign to each element? So we have an element in A. Okay, we have this element in A, and this element is called X. And this element is from the input, and the function applies to it. Okay, so the picture is that input supplied to the function. So the function apply its rule to the input, it produces exactly one output. So what's the concept of domain? The concept of domain, is all possible values that are qualified to be the input for the set function. All of them. For example, the law of the United States. Who do the laws of the United States apply to? Everybody on the land. No one is an exception. Do we agree with that? At least that's the spirit of this land, right? And that's also the reason many of immigrants came to this land or have coming to this land, because this land is supposed to be what? The land of the free, the home of the brave, but the law of the land applies to everyone. So when we talk about the domain, everybody on the land, does that make sense? Without any exception, that's the domain. Could that law apply to someone in Paris? No. He's not on the land. But we want to include everyone that the rule of law applies. Okay, however complicated the rule of law, without exception. That's the meaning of a domain. You have to include every single number in the rule of mathematics without leaving one out. If you leave one out, you lose a point. That's the concept of domain. And what's the concept of range? What's the concept of range? Range is the consequence of domain. Okay, what are the possible, for applying the rule to every number, in the domain, which is qualified for the rule to apply to it, and each one of them produce exactly one output. Yes, sometimes there are a lot of them. The collection of the consequence is a range. Do you guys follow me? Without leaving one out. All possible outcome. Outputs as a result of applying the rule of function to all possible inputs. Well, examine my words to see if there's anything you have a question with. So that's the domain and range concept. And that's what we've been trying to focus on this semester. So recall what we did for tangent. For that rule of tangent, what is a domain and what is a range? So now tangent is the rule. We talk about the tangent, this rule of tangent applies to angles. Radians or degree doesn't matter. Produces what? Produces ratio. Produces ratio. Okay, what kind of ratio is dictated by definition? And what is about in definition? In the definition, we have a set stage, right? Upon a point on the terminal side of the angle. You have to have these definitions in your head all the time. We've been on these topics for weeks. Why do we have to be on these topics for weeks? If I want you guys to memorize, I can give you everything in one day. Go ahead and memorize it. What will be the consequence if you have that? You cannot apply, okay? You will not be able to apply. You will not be able to solve a single problem with all those tables only without a proper understanding. Don't you agree with me? Well, at least that's true for myself, right? Even if you're 10 times smarter than all the professors in the world, math professors in the world, you still cannot comprehend with those answers and table. You have to understand, okay? You have to understand. I personally cannot function if I don't understand. So with that set stage, it's y over x. Okay, so y over x, right? So we have a narrative. What is a narrative? What's a narrative, right? The narrative is ARD, right? What is A, what is R, what is D? So for this A, we have specifics. So how is A determined? The A is measured from that standard position, either counterclockwise or clockwise. That's it. That's the rule. And R, reference angle, the acute possible positive angle between the terminal and x-axis. And definition. So this, on the definition, we choose a point on the terminal sides other than the origin, right? So you guys need to speak these fluently. Okay, so now what's the domain for tangent? What's the domain for tangent? When you think about these concepts, you need to think about these fundamentals. These are the fundamentals, right? Sometimes we have students, you know, I know professors not only teaching in community colleges and teaches 4-year schools. Okay, sometimes I actually know some professors in some university you guys may want to go to. And they often have students come up to before the final exam, before midterm exam. You'll say, hey, Professor so-and-so, Professor, John Doe, whatever. What are you going to be testing us on? this professor will, usually he will reply, all right, I'm going to test you on the basic stuff. And when you see the test, and then you see, oh my God, this is not basic stuff. Whether you made it, you did the test well or not well, after the exam, you go to the professor's office hour. If you do, the professor will explain every question. He can explain to you every question, every single question on the test in terms of the basic stuff. He did not lie to you. He did not lie to you. It's just usually our student did not understand what is the basic stuff. Okay? There's no need to apologize. There's no need to apologize for anything, okay? My job here is to bring you back to the basic stuff. Because I personally benefited from focusing on that. Like I always say, I cannot teach like Einstein. I'm not him. Okay, he's probably 100 times smarter than I, but I still cannot teach like him. I can only teach from what I understand. So I'm sharing my experience with you. And I believe this sharing will help you, which had helped me. That's the limitation I have. Okay, so once in a while, I will see my student is not on the focus, not focused on the same thing. I have to bring you back. I have to bring you back on track. Okay, that's why I want to mention these definitions over and over again. Any single moment you forgot about all these basic things, you're looking out for shortcuts. That's why you lose points. I assure you that happens 99% of the time. You may get away with it once in a while, not for too long, not for too long. Okay, so now what is the domain and range? What is the domain for arctangent? Right? You see, when you need that information, you look through your notes and you may end up on the wrong page. Right? You end up on the wrong page. How do you sit there and think for yourself? In other words, how can you do that? Think for yourself. Well, for now, you're thinking for yourself in the math class. You just want to get over it. You're going to move on with your life. But in your life, this same technique applies to our life. How do we think for ourselves instead of being influenced by other people's opinion or in other information to make that, well, somewhat a better decision? Math is training us to do that. It's called a critical thinking skill. But where do you thinking from? What do you think from? Right? The fundamentals, the basics. So what is the basics? At the beginning of the semester, I told you, this semester, the theme of this class is function. Have I left that mission for a minute? I told myself over and over again, I need to commit to that mission. I need to commit to that mission. Every single day I address this. Don't you think this is important? Otherwise, why do I do this? And this is also the way you study your calculus classes. You focus on the definition of limit. You focus on the definition of continuity. You focus on the definition of differentiability. You focus on the definition of integration. That's how you study, okay? And dig deeper. Every question you do, you dig deeper. Then every question on the test for you is going to be about the basics, and you are going to ace it. And this is from my own experience. I'm speaking from my own experience. Okay, I told you how dumb I was, right? It took me 4 times to pass the driving test. Even as dumb as I, the reason I can pass, you know, the grueling schooling I had from undergraduate to graduate school is by, these are the lessons I have learned. These are the lessons I'm sharing with you. I want you guys to see that way, okay? It's not about memorization. It's not about memorization, okay? All right, with ARD, can we figure out the domain of tangent? We just talked about, we just mentioned A, we just mentioned B, and we mentioned R. Now let's look at D. From definition, right? So let me do this one more time for you. Okay, I will do this 10 more times, 100 million times for you. Because this is the fundamental. This is the fundamental. As a student, have I made a mistake of straying from the essentials? Of course, I've done it many times. And I have reaped the consequences. I have reaped the consequences. I know. Okay, I know. All right, so back to the basics. Back to the basics. How do you figure out the arctangent? I'm sorry, the tangent domain? All right, x cannot be 2k plus 1 pi over 2. Very good, very good. But does everybody know that? Does everybody understand how it's being figured out? It's from definition, right? Whether you memorize it or not, right? We have a standard position. Okay, so let me, am I too slow, or what we should just go from there? Do you want me to continue to show you how you figure out from the basics? Do you guys want to hear that? Because I can take the answer, you know, Vincent gave us on the chat, and I just move forward. Is that okay? Is that okay with you? And Hazel said, yes, you want to hear it. You want to hear what I have to tell you, yes? Should I do it or not, Bruce?
Practice makes it perfect, better, faster, therefore easier next time. Practice, I believe in that.
Okay, so let's do this, right? Definition. Math is not about putting yourself on autopilot. Oh, I remember this, I remember that, I put them together. No, you constantly think, you constantly are thinking, you constantly are thinking. Okay, I'm making connections. That's a training you're getting. That's a training you're getting. Okay. So now we have that standard position, ARD, right? So how do we apply that? Well, you measure from the standard position, right? And you measure counterclockwise or clockwise. And then you have a terminal, and that terminal, you pick arbitrarily any point on that terminal, because it doesn't matter which point. We went through that, right? Doesn't matter which point. And this point has a coordinate, x comma y. Remember we did the 4 quadrant, right? In the previous weeks. You can't forget about it. You can't forget about it, okay? They're all connected. They're all connected. So x comma y. How is tangent defined? How is tangent defined? Tangent is defined as what? Tangent at that angle is y over x. That is the key to the domain. Don't you guys see that? X, as a consequence of this definition, as a denominator of this definition, x cannot be 0. X cannot be 0. And then x can be anything but 0. then when will x be 0? So your question is, when will x be 0? So anything that causes x equals 0 cannot be in the domain. Those angles cannot be in the domain. Do you guys follow me? Yes? What will be the x here? If you pick any point on this line, because you cannot pick origin, right? Can x be 0? No, x will not be 0, right? If you have another terminal, right, over here, will x be 0? You cannot pick the origin, right? Because the definition said other than origin, the definition is flawless. Okay, in this case, x will not be 0. Keep going. When will x be 0? This is the case. X will be 0. So this is the terminal that will cause the tangent undefined, right? You can have a 0 denominator because y over x is going to cause it equal to 0, right? But it have a 0 denominator, right? So this terminal, so how many angles are there that will end up on this terminal? So this terminal is the forbidden. But ending at this terminal, how many angles could there be? Infinite. What could it be? Right? If you measure those angles, pi over 2, right? You go around 5 pi over 2. You keep adding 2 pi, right? You adding 2 pi clockwise, counterclockwise. You need to have this in your imagination, guys. You need to have these in your imagination. It's all about ARD. So whether you measure counterclockwise or clockwise, whenever you terminate on this piece, whenever you terminate overlapping the y-axis on the positive direction, you're going to cause a 0 denominator, and therefore those angles cannot be in the domain. Do you guys hear me? You guys hear me?
Yes.
All right. So this is a forbidden terminal, right? What else terminal is forbidden? Do we have another one, right? Because domain has to describe all possible number can be in it, or it also tells you what are the numbers that cannot be in it, right? The next one is this one. This is a terminal that it cannot be. And what is that terminal? Right? So once we have identified the two terminals, then all the angles that ended up at those terminals, those angles cannot be in the domain because the input for tangent are angles. Do you guys follow me? How are the angles measured? A, R, D. Do you guys see that? That's what I want you to see. You get it? Yeah? The same way you figure out a lot of things. Okay, pi over 2, we cannot be 3 pi over 2, 5 pi over 2, 7 pi over 2. It can just keep going. So that's how we get odd number multiples of pi over 2 are the angles the input for tangent cannot be. Yeah? Any questions? Any questions? And what have we done for tangent, right? So if I go back to the lectures, there's a section we did tangent, right? We observe, we know that the tangent is going to have pieces, right? Because there's a divide, pi over 2, right? So from excuse me, from 0 to pi over 2, you have a piece, but then there's a break. Excuse me, and then you get to the next piece, and you have another break, 3 pi over 2. So between, okay, so now we figure out the domain. We figure out the domain. Okay, let me make this smaller, right? So what's the description of that domain? What's the description of that domain? So A cannot be what? Odd number multiples of what? Pi over 2. And how do we describe odd number multiples of pi over 2? We talk about the odd number, right? How do we express odd number? 2k,
2k
plus 1
plus 1 or 2k minus 1.
or 2k minus 1. You don't have to use both, just ones will be fine. And k is any integer. Are there any questions about this one? Right? Are there any questions about this one? Do you guys get the thinking process? It's that thinking process I'm teaching you. I'm sharing with you. Okay, so when I think of this question, I'll be thinking the same thing. But oftentimes we say, well, we think, we study, but where do we study from? Always from the basic concept. You dig a little deeper. You read it one more time. You read it 10 more times. But every time you infuse some more examples. So the homework, as you read those key concepts, when you do your homework with those key concepts in mind. Okay, and that's how to get the grades. That's how to make the grades. All right, so with that said and done, what do we realize? The numbers between what? A cannot be what? It cannot be what? It cannot be pi over 2, right? Positive, negative pi over 2. So if you look at the number line, you line up where you're gonna write pi over 2, right? You arrange them in a certain order. 3 pi over 2, right? 5 pi over 2, 5 pi over 2. And what else? 7 pi over 2. And so on and so forth, right? You keep going. In the other direction, you have negative pi over 2, right? And you have negative 3 pi over 2. Imagine these numbers are arranged on number line. Imagine these numbers on the number line. That's how you get those pieces on the tangent. Is that right? And there's many numbers before and after. So the tangent curve, what happened to the tangent curve? What happened to the tangent curve? They are between what? They are between these numbers. All these curves are between those numbers. So what is it? How do we read this? All real numbers except what? This guy. That's how you read it. So the domain of tangent is described using the exclusion method. Exclusion. You guys follow me? So between these pieces, All right, between these pieces, what happens? Okay, so let me just make it a little bit more dense. But I can never complete this picture, right? So now on this piece, there's some vertical asymptotes some of you recognize, right? So what are those vertical asymptotes? Those are these numbers. These numbers. So pi over, sorry.
Professor, some typo right there, maybe -3 pi over 2, -5 pi over 2, is that?
All right, negative. Thank you.
You're welcome.
Okay. So all of these points, for example, where's negative pi over 2? Negative pi over 2 is a vertical line. Okay, negative pi over 2 is a vertical line. Broken line, let me use a broken line. I'm going to use red for the moment, okay? Forbidden. And that point is a negative pi over 2. Negative pi over 2 cannot be in the domain. As a consequence, the curve cannot touch it, cannot touch this vertical line. Okay, so if you draw a vertical line right here, it's not going to touch the curve. We have studied that in the neighborhood of pi over 2, right? We're approaching pi over 2 we're approaching negative pi over 2. We have studied those, didn't we? We choose 89 degree, 89.99 degree. Didn't we do that? Did we do that? Do you guys remember that? I cannot redo that today, okay? You guys go watch those lectures, right? So now, wait. What's going on here? All right, so, and let's draw another line. I want you guys to have the piece of paper with you. You draw this, you sketch this, okay? And we're gonna put these together. We're gonna put these together, okay? Pi over 2. So I'm gonna draw all of these for you, okay? But you must do it yourself, okay? So this is, you see this line, this vertical line, okay, this vertical line is A equals to negative pi over 2. And that vertical line is A equals to pi over 2. Okay? These are the forbidden, no flight zone, no flight zone. You cannot fly over. Got it? The curve cannot fly over. Separated. So these pieces, right? So let's draw more pieces. You can see what it cannot be. What it cannot be, right? Positive, negative 3 pi over 2. That's on both sides. 5 pi over 2. That's on both sides. And so on and so forth. You guys follow me? You want to visualize them and arrange them in this order from smaller to larger, and that's what you get. These are the values that A cannot be. Do you guys see that? Do you see that correspondence? And those numbers will cause the denominator equal to 0. Okay, so keep going. I want you guys to draw this on your paper pencil. It doesn't have to be precise. Okay, don't just do it. Don't just punch your calculator and give you a graph. You must do this on paper. Let me tell you, when you write and use your paper pencil by your own hands, when you write that down, it does miracles for you. The miracles that beyond which is what you just see, because it builds something at your subconscious level, I believe, okay? That's how it helps you when you need it. All right, so let's keep going. So -3 pi over 2, right? So I'm going to put that there. Okay, so -3 pi over 2. And then I'm going to keep going to put all of those there. +3 pi over 2. Yeah, I need to remember some of you never had a trigonometry. For those of you who didn't have trigonometry, I really think you should go take trigonometry. Okay, I'll do my best to accommodate you. So because at this point of semester, there's nothing you can do. You cannot take any new classes. Okay, you just have to make the best out of it. Okay.
Or a stop by Math Study Center.
You have to work extra hard to make that grade. But this is not to say people who have taken trigonometry does not mean this. Okay, I believe all of our students need this. That's why we have the course called pre-calculus. Okay, but people without trigonometry, it's even harder. Okay, there's one there. So we have put all of these vertical asymptotes. Okay. And all of these asymptotes, as I marked here, they're all about those forbidden numbers that cannot be used as input for tangent. You guys see that? Okay, that's what it means. That's the visual of all number multiples of pi over 2. So on both sides, okay, on the negative side, on the positive side, we arrange them in this order. So this function obviously has no inverse, right? It doesn't pass the horizontal line test, doesn't it? It does it, I'm sorry. It doesn't pass the horizontal line test, right? Agree? Agree? Tangent. Okay, so let's go back to our sentence, right? We go back, we talk about it. Tangent is not a one-to-one, thus it does not have inverse. So how do we introduce arctangent? How do we introduce arctangent? Okay, how do we introduce arctangent? I'm going to put this very top. Okay, so that serves as a review. So how do we introduce tangent? Arctangent. How do we make it one-to-one? In fact, we can choose any piece, right? I can choose this piece and just truncate. Okay, truncate the rest of it from here. I just leave this piece, right? Chop, chop, chop. I can use this piece and I can use this piece and chop the rest, right? There's many options. There are many, many options. For each option we chose, we will be able to create a new function, which is one-to-one, right? We create a one-to-one function. If it's a one-to-one function, then we'll have inverse, right? We'll have inverse. That's the idea. So among all of these pieces, which one do you think is the simplest to the first mathematician who defined this? Which one do you think the simplest piece?
The one that contains the origin.
That's right. Great minds think alike, right? So the first mathematician who defined this, he decided, okay, I'm going to chop this off. Everything is all chopped off. Gone.
No fly zone.
No fly zone. Okay, we're going to look at the unit circle, right? What the consequence on unit circle? Every action, every word has a consequence. We agree with that, right? Words has a consequences, and words in mathematics has a consequence. These chop, right? These chop has serious consequences. Okay, so after this chopping, what do I get? Okay, after this chopping, what do I get? The consequence of this chopping. Okay, I'm getting a new picture. I'm getting a new picture. Okay, but how do I show you the new picture? I will adjust the view. I will adjust the view. Okay, so how do I adjust the view? Okay. Approximately. So this is the consequence. Okay. If I want to also include, the vertical asymptote, this is the consequence of truncation. You guys follow me? So that I put everything in the same view. So that's the chop. Okay. We just talked about these 2 points, right? One is negative pi over 2, the other one is pi over 2, right? There's a 2 vertical lines. So can you guys mark these 2 vertical lines for me? I just magnify it. So this is the consequence of the chop. So what's being left? What's being left is just this piece. What's being left is just this piece. Okay. Just this piece. Just this box. Just this box. When I magnify this green box, it's over here. So can you guys mark these 2 vertical asymptotes for me? That's A equals to negative pi over 2. And that's what's happened. That's A equals to pi over 2. The 2 vertical asymptotes, along with many points on the curve. Along with many points on the curve. You guys follow me? Many points on those curve. Some of those are special angles. Some of those are special angles. Some of those are not special angles, right? I have given you guys some homework on special angles and non-special angles. Remember that 32-point quizzes I give you guys? That's a non-special angle, right? Some of those may be on there, maybe on there. Okay, so it include all the special angles and non-special angles. So let us look at the consequence on the unit circle. Let's look at the consequence on the unit circle, okay? So let's look at the consequence on the unit circle. I'm going to clean this up. Okay, I'm gonna clean this up. Where's my unit circle? Come back. There. What is the consequence on the unit circle? Okay, I'm gonna make this just a little bit smaller because it's just being there for us, right? After we chop it off, what can be the input? 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 The input are the horizontal choices, right? The numbers horizontally. So what are they? They're from negative pi over 2 to pi over 2. Does it include a negative pi over 2? Does it include a positive pi over 2? Of course not, right? So the truncated tangent will have input from negative pi over 2 to pi over 2. So let's write it down. Okay, so the new function tangent, right? The new tangent function, right? After that truncation, A is from negative pi over 2 to pi over 2, not including. So it's exclusive, less than pi over 2. So that's the input. What are the output? The output are ratio. What a ratio? Y over X, right? Y over X. And we have done it. The blue number divided by the red number. You guys follow me? The blue number divided by the red number. Remember we did that? It's still that. But because the input is restricted from negative pi over 2 to pi over 2, on the A, remember ARD, what's the implication? Every angle for the input of trig functions, on sine, cosine, that defined in the trig functions, they are measurement of angles, right? Angles measured from which direction? Starting from the standard position. So you measure up here, you can get as close as possible to pi over 2 because it cannot be pi over 2. We can be close, 89 degree, 89.99 degree, and so on and so forth. Remember we did those exercises? So in the counterclockwise direction, you can only measure up to here as close as possible to pi over 2. In the clockwise direction, you can only measure as close as possible to negative pi over 2. Never touch negative pi over 2. Never touch that terminal. So you're bounded by this piece. First quadrant, fourth quadrant. What happened to the third quadrant and second quadrant? Huh? No flight zone. No flight zone. Right? No flight zone. So that's what it tells us. So this new function with that specifics. Okay. Now this function 1 to 1. In fact, it's increasing. Increasing is 1 to 1. Therefore, it has inverse. Okay. So if I call this function g, okay, 1 to 1, it has an inverse. It has a unique inverse, right? It has a unique inverse. The same story, right? The same story. So that's the domain. And what's the range? Remember we did those points, 89.99, 89.999. Remember we did that? Do you think we did that for nothing? It's over? No. What's the range? What is the range for tangent? The picture is right in front of you. What's the range?
Negative infinity to positive infinity.
That's right. Correct. Vincent, great job. Okay, so that's the domain. The range is from negative infinity. Why do you think I did that then? Why do you think we did that then? You think that's going to be no use? Just use once for that matter of fact? No, remember we did the limit from the left and right and on this side and that. You guys need to go back to study those lectures, okay? You need to study those lectures. Go back. You need to watch those lectures over and over again. All right? Okay? So we talk about these properties, how to analyze, right? And in this case is It's off of left and right and all of that thing you need to look because that's your calculus class is going to use them. Your calculus class will use this, okay? I'm not joking. I'm not joking at all. Right. Okay, go back to review those, okay? We will get you some points in calculus class. Now, I'm going to put this on the side on this function. I'm going to put this function on top. I'm going to put my unit circle with me. Right? So we have recognized a no flight zone. No flight zone. Now we know this function has a domain and range. And what will happen to the inverse? Before we give it a name to the inverse, we know that inverse exists. We know that inverse exists. And we also know the domain and range of that inverse. What will be the domain and range of the inverse? Before I give it a name, what will be the domain for the inverse of G? You tell me. Any pair of functions that are inverse to each other, they're uniquely to each other, right? There's a unique pair. One's domain is the other's range, vice versa. So the domain for the inverse of tangent defined in this interval, the domain will be from negative infinity to positive infinity, and the range is going to be from negative pi over 2 to pi over 2. Before I give it a name to it, I already know the domain and range for it. Okay, this is how this set of analysis, okay, truncation, all that connection. If you understand it, you never have to memorize it. Are you going to use the inverse for, we're going to call it arctangent? Of course, you're going to use it in calculus, okay? Guaranteed. That function. All right. Now, how does it look? How does it look like? That's the question. How does it look like? Right? We understand that from, so we're going to do similar drilling. We're going to do similar drilling like arc sine, arc cosine. So first, before we graph this function, I'm going to graph with you. And we're going to identify some points on this tangent curve. Okay, on this piece of tangent curve. So you guys need to do some work. Okay, these work are not, most of them are not new to you. It's just we limited to this interval, right? I'm going to give you the point and you guys are going to do the calculation. If you like, you can dig out the notes from before and we're going to see what happens at the, close to pi over 2, negative pi over 2, what happens? Okay, are you guys ready? Yeah? Are you tired? Are you tired? No response. Where is everybody? Okay, so G is a function, we need to understand. G is a function that takes input as angles and produces ratio. You see, I start to emphasize this from the beginning. Okay, from the beginning. You must make sure you understand. If you don't, you need to let me know. Okay, so for G, So I'm going to give you some input, okay? These inputs are negative pi over 3. Okay, negative pi over 2, negative pi over 4, negative pi over 6. Okay, you have the unit circle next to you to help you to get those ratios, okay? And 0, okay? And more numbers. Okay, so pi over 6, pi over 4, pi over 3. Okay, but how about the numbers closer to pi over 2? We cannot equal to pi over 2 for sure, right? We cannot equals to negative pi over 2 or positive pi over 2. It cannot be, right? Not in domain. This is not in domain. Okay. And the other one is pi over 2. It cannot be. It cannot be the input, right? So here it's undefined. Undefined. And over here is undefined. But what if we want to get closer and closer to it? What if we want to get closer and closer to it? We want to get closer and closer to it. So I'm going to choose some degrees. I think that might be a little bit easier, right? Getting closer and closer to negative pi over 2. In the other direction, we're going to be closer and closer to pi. This is actually calculus stuff, okay? Okay, closer and closer to pi over 2. So I'm going to give you some numbers. Okay, you're going to punch in calculator. So first do these values. Okay, so first do these values. All right, so let's do these values first. I don't want to overwhelm you. Should we have breakout rooms? You guys need breakout rooms?
I'm preparing my table, Professor.
Okay, so how about you guys just do these values? Okay, you do the ratio of blue over red, right? You know that, right? That's the ratio of blue over red. Yes? Blue over red, you can do that, right? Hold the special angle, the numbers in front of you. That's the definition of tangent in simplest form, in the simpler form. And then we're going to arrange the angle and the tangent ratio. So this point doesn't exist because it's undefined. So then you're going to have all of these points. Okay, all these input outputs. Okay, so you're going to set them up. Right? Set them up. Set them up. To fill those blanks. Do you need breakout rooms? I know that, you know, Farouz is always eager to help.
We got one response, Professor, yes, on chat.
All right, breakout rooms. Self-assigned. Open. Okay, but even though we're doing this, you still need to go back to watch those other lectures, okay? You need to watch the other lectures. So what you need to do, oh, sorry, this is A, my bad. Okay, they need to be consistent. I'm going to give you any examples. We have done this before. We've done this before. Okay, so for negative pi over 3, we measure the angle. It's just ARD. It's just ARD, really. Negative pi over 3. Okay, that's the terminal. And the blue number is negative root 3 over 2. Okay, so the blue number is negative root 3 over 2. And the red number is, unfortunately, I cannot do the red number. I can do the blue and red here. Okay, this software is limited. So we end up with, so this is a negative. So that's going to be negative root 3. If anybody has any questions about how to simplify that, you multiply 2 on the top. Okay, you multiply 2 on the top. So you multiply by 1. Multiply by 2 on the top and bottom. That's how you get negative root 3. So this point is a negative root 3. Okay, so add a negative pi over 3. So that's how we get it. And this one, okay, so that's for negative pi over 3. You plug in the numbers like that. You plug in the number like that. You plug in the number like that. Write it this way, please, okay? You write it the way I do. The blue number is a negative root 2 over 2 over root 2 over 2. It equals to negative 1. So the output is a negative 1. Negative pi over 6. Because in the process, you learn the right way to express yourself, okay? Don't use any shortcut. Remember, this is 5 classes in 1, okay? We're reviewing a trigonometry concept, but you also, at the same time, we review up to, all the way down to pre-algebra. Throughout the algebra classes, we review everything. So over here, this is going to be negative half. Okay, negative half. And negative root 3 over 2. Okay, no, positive, sorry, positive root 3 over 2. Okay, and we simplify this quantity. You multiply by 2 on the top. You multiply by 2 on the bottom. Principle number 1, and then you get a negative 1 over root 3. Okay, and sometimes we rationalize it. So we multiply root 3 with over root 3. And so in the end, we get negative root 3 over 3. So that point is negative root 3 over 3. Okay? So you do this one by one, which is work on the table, and then we're going to plot the points. So 0, 0, at 0, the blue number is 0. The red number is 1. Okay, so that equals to 0. 0 divided by 1 is 0. 1 divided by 0 is undefined. Okay, so that's 0. Pi over 6. Pi over 6. Okay, In that case, the blue and red, that's going to be positive, positive. Okay. So go through the same, go through similar steps. You're going to end up with 1 over root 3. And then you rationalize it. Okay, so you times 2 on the top. You times 2 on the bottom. And in the end, you get root 3 over 3. So you do this one at a time. Am I too slow? So that's a root 2 over 2. Okay. And we got a positive 1. The last one, pi over 3. Okay. For pi over 3, I'm just going to copy that. Okay, so over here is a positive 1, and over here is root 3 over 3. And over here it's root 3. I go into this over, we've done something similar before, but it is very important that you understand this and you do this again, because you're going to need this in Cal. Okay, so now we have 7 points. We have 7 points. Now we're going to put these points on this tangent curve. This piece, okay, this slice, okay, not the entire tangent. It's after truncation. It's after truncation. Okay, so I probably, this is too big, 125%. Okay. So let me close the rooms. And then we're going to put the points on the chart. We're going to put the points on the chart. So you just multiply by 2. I multiply by 2 over 2. Multiply by 2 over 2. Okay, it's as if I multiply by 1. Okay, anything times 1 stay the same. So 2 over 2. Can I explain? Okay, root 3 over 3. For root 3 over 3, first of all, I put in, okay, so before it's a half. Do you see that? So that is a half. Half over root 3 over, then we multiply by 2 on top. We multiply by 2 over 2. Okay, and after that, we get 1 over root 3. Okay, do you see that 2 and 1/2, that becomes 1. 2 times root 3 over 2, that becomes root 3, yes? And then we multiply another 1. Okay, anything times 1 stay the same, and this one is chosen to be root 3 over 3. Root 3 times root 3 is 3. Okay, that's root 3. Root 3 times root 3 is root 3 squared. That equals to root 9. Root 9 is 3, yes? Did you get it? Someone was private message me asking me how I get this. Okay, So that's going to be, that's how we get root 3 over 3. Is that clear? Okay. All right, welcome back, Faruz. Thank you for helping those students. So let's see. For these 7 points, can you find a spot for them? So far, we're still doing the tangent, right? But it's a truncated tangent. It's a truncated tangent. We haven't talked about arctangent yet. Okay, we haven't talked about arctangent yet. So shall we put the points in place? Okay, I'm going to make this tangent curve to be green. Okay, I'm going to plot these points in place. So this point will be on the spot. It doesn't have to be perfect. It doesn't have to be perfect. However, how do we make it better? We mark the points. We mark the points. Okay, so that's 1 point. Negative pi over 3, negative root 3 over 3, a negative root 3. Okay, negative pi over 3. So the angle is the input. The tangent ratio is the output. Angle input, tangent ratio output. Angles input, tangent ratio is the output. Okay, so then we do the next point. Negative pi over 4. So we're gonna mark the points all together. Okay. So we're gonna add the point. Add another point. So that's negative pi over 6. Right? So that's gonna be negative root 3 over 2. And root 3 over 3, sorry. Okay. So these are the 3 dots over here. And then we have the 0. We add a 0. Okay, we have the 0, and then what? And then what? And then what? We just keep going, right? We just keep going. All 7 points. All 7 points. Is everybody with me? Is everybody with me? Now we want to make some connections. Okay, now we want to make some connections. The input I couldn't emphasize enough how important it is for you to understand this. Okay, the nature of the input is not the name, is not the color. Okay. This is the tangent ratio. Okay, what is that tangent ratio? In definition, it's y over x. Okay, so the points we show on the green. But we also recall how the picture is made, right? How the picture is made. How the picture is made. For example, if I have pi over 4, right? Take example pi over 4, right? I will measure pi over 4. And I pick that point on the terminal. So this is pi over 4. For pi over 4, there's a peak of arc, right? Arc length. So this arc is stretched straight. Like that. And the tangent ratio, right? The tangent ratio let's see what color. This time is neither red or green. It's going to be this much, which is 1. Okay, so our proportion is not that good. So I'm going to make that proportion correctly. Okay, so this is pi over 4 and that ratio is 1. Okay, so you can see this is from 1 to 5. So this is 1, 2, 3, 4, 5. That's right, right? So this is about that point. So how do we mark this point? How do we mark this point? Huh? How do we mark that point? Can you guys mark this point? How do we mark that point? How do we mark that point? That point will be marked by orange. Pi over 4, comma, okay. And the ratio, I'm going to write it this way. The ratio of blue divided by red. I hope this way will make the maximum connection. Okay, then of course that ratio is 1. That ratio is 1. Do you guys follow me? Do you guys follow me? The arc length is still used. The arc length is still used. But instead of sine ratio or cosine ratio, this time is tangent ratio. That's blue divided by red. Okay, y divided by x. Got it? Everybody? How are we doing? How did we go? How did we do, Farouz, in your group?
We did good, Professor. And then, of course, we had a little bit, we didn't have enough time, but we start filling the table and using the unit circle. Visually, we were, using those value ratio of blue over red and getting the answer very well.
Okay, so when they operate on these steps, they needed help, didn't they?
Yeah, that was a complex fraction ratio and algebra, take care of the business, complex fraction.
Okay, thank you. So
Yeah.
you can see you guys taking this class is really 5 classes in one. You're doing 5 classes all at once, right? Because reducing the fraction is elementary algebra. And the concept of trigonometry, those are in trigonometry. Right? So you guys are brave. You're taking on 5 classes in one. You're amazing. I'm not as good as you are, okay? I did it step by step. I did it in elementary algebra, intermediate algebra, trigonometry, and then we take calculus. You guys just 1 semester, 5 courses in one. That's a big task. That's a big task. Okay, I wish you guys the best of luck. All right, so this make the, why do I use the color orange here? Tell me, why do I use the color orange? I just said to maximize the connection. So what is the connection? What is a connection? Because I have been using orange color for the arc length, haven't I? Yes? Do you guys recall that? Yes? No answer. Are you guys sleeping?
You use the orange for arc length,
I
Professor?
use the orange for arc length. I have always been using the orange for arc length, right? Yes, that's the connection I want to make. So in all the previous lectures, when we graph sine curve, cosine curve, I've been using the orange color for arc length, the red color, the green color, and so on and so forth. Are we being consistent? I hope you see that consistency. Do you? Do you see that consistency? Yeah? Okay, thank you. All right, so for each of the point, okay, we're near the end of the class. So you understand that orange color coordination and the ratio. Therefore, now I'm just going to clean up and we have a closure for this point, for this graph, okay? We just did the points and we're going to continue on this tomorrow, right? So we're going to mark the points. We're going to mark the points. The proportion is still not perfect, right? The proportion is still not perfect, but this is 1 and that's 1, right? So it's okay, right? It's okay. It's not too bad. So I'm going to mark the points accordingly. I'm going to mark the points accordingly. So this point, okay, the orange color, which is pi over 3. The ratio, which is the purple, is going to be √3. You guys see well that? And this point, this next point, right? That's pi over 4. And the purple ratio, which is the blue over red, is going to be 1. And this point, okay, this point is pi over 6, comma, √3 over 3. Oh, sorry, wrong color. Okay, we're going to use the purple color. √3 to 3. Okay, and this point, of course, is 0. So the orange is 0. The orange is 0 means that the angle is 0. And the ratio is 0. That means the purple 0, okay? The nature of their quantity, angle to ratio, angle ratio, angle ratio, angle to tangent ratio, angle to tangent ratio. Do you guys see that? And next, the points on at the bottom, okay? So the orange color is a negative pi over 6. And the negative √3 over the orange color, the purple color, which is going to be negative √3 over 3. My handwriting on the board is much better, right, Farouz?
Practice makes it perfect, whether faster.
I've been practicing, but I don't think I have improved much.
It is very nice, yes. Especially using the color code is very useful.
So,
Helpful.
negative pi over 4. When I was on site, I had a student. She gave me different colors of chalk, but I cannot use them right now. So this is -1 being purple. Okay, the last one, finally. The orange color, negative pi over 3. And the purple color, negative √3. All right, are we good? So what is that purple? The purple is red divided by red, the blue divided by red, right? Is blue and red mixed together makes purple? I don't know. I'm not an artist.
Yeah, it does.
It does? Oh, yay. I'm happy to hear that. You must be an artist. I'm terrible with colors. I'm terrible with colors. That's why I have no choice. I cannot be an artist. You cannot be an artist. All right, so today, I think that's how much we can do. Okay. I made some typos on the homework assignment yesterday, so I have just corrected it. It took me 2 hours, but to tell you the truth, okay? To get things done on the software, it just takes a lot of time to get it done properly. But anyway, I'm glad to report to you, and I think those are done correctly. And so your homework is now available. The tables are okay. The tables are were available yesterday, so you can completely you can complete plotting the points on the graph. And also, I've given you quiz number 15. Okay, well, delete the 15 last week. Just this is a new 15, and quiz number 15 is going to be available soon. So I wish you the best of luck. But quiz number 15 is about arc cosine. So you guys got that. And today we're doing arc cotangent. So you have another quiz coming your way this week, and it will be about arctangent. Okay, and its related properties. And I'm sure we're going to finish arctangent this week. So without further ado, I will see you guys on Wednesday. Shall we?
Thank you, Professor.
Very good job, you guys. And it's very, very important that you let me know you have questions on anything, please, on anything, okay? We want you to make the best of it. But we don't know you enough to know what you don't know. We don't know what you don't know. So any question, every question, just bring them along, okay? I'll see you guys on Wednesday. Have a great the rest of the day.
Thank you. See you tomorrow.
See you tomorrow. Thank you, Varus.
Thank you for the lecture, Professor.
Of course, anytime. Thank you for the participation. Great job.